Welcome to the Assigning Oxidation States podcast. In this podcast, I'm going to show you how to assign oxidation states to any free element, compound, ion, or even a reaction. Assigning oxidation states to a reaction helps you determine if it is a redox or oxidation-reduction reaction. If it is a redox reaction, something's always oxidized, which means it loses electrons, and something's always reduced, which means it gains electrons. To figure this out, you'll need to know how to assign oxidation states. There are a few rules, so please pause and write these down. Rule number 1, any free element has an oxidation state of 0. Iodine, oxygen, potassium, aluminum are all oxidation states of 0. Rule number 2, the oxidation state for a monoatomic ion is its charge. Iodide ions have a charge of -1, and so their oxidation state is -1. Oxide ions have a charge of -2, and so their oxidation state is -2. This is explained in periodic table. Iodine needs to gain 1 electron to reach its full octet, and oxygen needs to gain 2 electrons to reach its full octet, and so that's where the charges come from for the ions. Rule number 3, oxygen's always -2. So the first example, iodate, oxygen's a -2 because that's the rule, and there's 3 of those, so that's -6. And the sum has to equal -1, so iodine is +5. In peroxides, oxygen is a -1 because if you were to do that out, work that out, and there are 2 oxygens, so that's -2, and that has to equal the sum of the charge. Rule number 4, hydrogen is a +1 in covalent compounds. H2O is a covalent compound, so hydrogen's a +1, and there's 2 of those, so oxygen has to be a -2, and that gives you a sum of 0. Hydrogen is a -1 in metal hydrides. NaH is a metal hydride. Hydrogen's a -1. Sodium's a +1. So that's a total of 0. Rule number 5. Fluorine is -1 because it's the most electronegative. The example for that is hydrofluoric acid, or HF. Fluorine's -1, so hydrogen's a +1. And that works because this is a covalent compound, so hydrogen is a +1. Rule number 6. The sum of oxidation states in a compound is 0. Manganese oxide, the first example. Oxygen's a -2, there's 2 of those, so manganese has to be a +4 to have a sum of 0. The sum of oxidation states of an ion is a charge, so oxygen's -2, there's 4 of those, and the sum has to equal -1, so manganese is +7. Now here are a few more examples. In the first example, fluorine is the most electronegative, so it is -1, and there's 2 of those, so oxygen has to be +2, and that gives you a sum of 0. Second example is a covalent compound, so hydrogen's a +1, there's 4 of those, so carbon has to be a -4. Third example, oxygen's a -2, there's 3 of those, and so to have a sum of 0, the other thing has to be a +6. But since there are 2 iron atoms, you have to divide by 2, so that's +3 oxidation state. And the sum would be 0. And the last one, I recommend you split this up into any polyatomic ions that you may know. Carbonate is one of the polyatomic ions, and I know its charge is a -2, so I'd go ahead and do that side first. Oxygen's -2, there's 3 of those, and so the sum has to be -2, so carbon is a +4. NaH, that is a metal hydride, which we already went over, so hydrogen is a -1, so that means sodium is a +1. Applying these rules in a reaction is simple. You just take it as an equation and take each term and do the same rules that you did before. So the first term, oxygen is a -2, there's 4 of those, and the sum has to equal -1 because of the charge, so manganese is a +7. Second term, oxygen's a -2, there's 2 of those, so sulfur has to be a +4. In the third term, that is a monoatomic ion, and the rule states that a monoatomic ion has an oxidation state of the charge. In the last term, oxygen's a -2, there's 4 of those, so that's -8, the sum has to equal -2 because of the charge, and so sulfur is a +6. Now I recommend you write these below the reaction to see and make it easier to determine if what was reduced and what was oxidized. if you look at this reaction, you can tell that manganese started at +7 and became a +2. So it gained 5 electrons, making it reduced. Sulfur started at +4 and became a +6, so it lost 2 electrons, making it oxidized. Now this reaction isn't balanced, but you'll learn how to do that later on. And this is important to know how to do because it is the very first step in doing redox reactions. And being able to do everything taught in this podcast will help you know to determine if something is a redox reaction and to be able to balance it out once you know if it is. And that sums up how to assign oxidation states. I hope you enjoyed it and learned something.